I'm gonna do Leetcode 242 valid anagram. So we're given two strings and we're asked to determine if they are anagrams. That is, if, for example, the same frequency of letters in one is the same as in the other. Like if you have AA and the other string is AA, they have the same frequency for A. And in that case, they are anagrams. It could be like AB and BA, the same thing. So you give these examples here. So there are different approaches for this. You could make like a canonical representation, sort the characters and see if there's no mismatch as you're traversing. But I'm not going to do that one because that one involves sorting, and sorting might go to O of n log n for the complexity. I'm going to do a more efficient one. And the key for this one is you have to understand the constraints. So if you scroll down, you're given the constraints consists only of lowercase English letters. So that's 26 letters, lowercase. So given that constraint, you can kind of formulate a solution that's more efficient than sorting. And basically, we're going to count the characters. So for example, in this example, rat and car. So we're going to go and traverse this. And we're going to come, if we see this letter R for S, we're going to keep track of it. Okay, count of R is 1. Then I'm going to look at the T. And if we see like the R again, we're going to actually subtract from the count because we want to keep like, if I see somewhere it's plus on the S side. If I see somewhere on the T, that means they match, right? Therefore, I'm going to subtract for the sum, for the count, so they become 0. So by the time I finish everything, I need to ensure that the count for every character that I've seen is 0. Because if I see on one side it's +1, if I see on the other side it's -1, so they have to come together. If we have an anagram, we have the like same frequency of letters. Now, one thing to keep in mind is if the characters have different lengths, the strings have different lengths, but right away is not an anagram. So that's a special case you can handle right away. So you don't have to worry about them being different. So let's go here. So the solution here is keeping a frequency of the characters. Now, because there's only 26 letters, I can just simply use an array of 26 characters or counts. But if you want to expand that to like Unicode of any kind of character, then you would have to actually use a hash map and make the counts for each letter. And then later, you would go through each value in that hash map and ensure that it is 0. Otherwise, if it's not 0, it's not an anagram. Okay, so to keep it simple, I'm going to make an array of ints. Let's call it counts like this. And I'm going to int new int in Java. I'm going to use Java, so you can create that with 26. So it's going to be like index 0 all the way to 25, initialize everyone to 0. Okay, in Java, when you say new int 26, every value is already initialized to 0, so I don't have to do a loop traversing to initialize. So knowing that, we're going to traverse. Oh, before that, we can just check if the s.length, because we have a string here that's not a primitive, we got to have the parentheses for length, is different from the t.length. Right away, that's not an anagram, so we return the Boolean value false. And otherwise, it's going to be you're going to, after that point, beyond line 6, you know for sure they have the same length of characters. So when I do my loop here, I know for sure it's either s or t that I can use for the condition. So int I equals 0, as long as I is less than s.length, parentheses. Could be s or t, doesn't matter, they have the same length at this point, I++. Okay, so, we're going to look at the character s, char at, the I. Now, there could be A, B, C, D, and so on. Now, we're going to do, how do we know where to place in this array, right? Let's assume that index 0 is for A, index 1 is for B, and so on. Now, in order to do that, I always have to keep my position relative to A. So there's a trick you could use. You could take the code point. For example, if the code point, the I was an A, it would be 97. If I could keep that, subtract 97, I get 0, which is relative. So you have this trick of minus the lowercase a here that you can do, or you can do 97 explicitly. And that should give you like 0, for example, if it's A. And then B minus A will be 1, C minus A is 2, and so on. So with that, you know what the index to use, okay? Now we're going to take this and use as an index to access, okay, the letter counts here. So at that index, we're going to either increment or decrement. Now we increment if it's for s, so we can do like this. So basically, if you don't understand what's going on, you can separate them. You can put this in a separate variable and so on. But basically, let's say we had like rat here. It's r, right? So char at 0 will be r, minus a will be like the difference to place in the array. So the counts at that position for the r would increment to 1 because we've seen an r in s. And then we got to do kind of the same, but for the t. So we're going to look at the t.char at I. We're going to subtract a to get the relative so we can normalize. And then at the positions of count, we're going to subtract 1, right? If you don't like that minus, minus, plus, plus, you can write it out. Count at this index equals count at this index minus 1 or plus 1, if you want to be more explicit. So when you see the same character plus 1 in S, when you see in T is minus. So if they have the same character, it'll be 0 at the end of all of this. If you have one character in one but not in the other, that's like extra, you're either going to see 1 or minus 1. Okay, so yeah, after that, it's just a matter of you got to loop again, but outside. So we're going to go outside, int I equals 0. We're going to loop through the counts. So it's just 26, right? So I can either write 26, but I want to make it more flexible. Counts our length. And we're going to check, okay, if the counts at the I not equal to 0, meaning, okay, there's some discrepancy. I saw a certain character more often in one. They don't have the same number of characters. That's right away return false. That's not an anagram. Otherwise, if I have traversed everything and then ensure that the counts is 0 for every character that I've seen, every letter, that means they match, right, on the frequency for each character. In that case, after traversing everything, I can return true here. Okay, so let's go. And there you go. Submit. All right, so the time complexity, we got one loop, another loop, but they're outside. They're not inside each other. They're not nested, so well then. All of counts length, which is like 26. And we add them together, it's going to be simplified to all of n. And space complexity, we're using this array of counts, but it's not varying given the input, right? So we could say it's O of 1, constant time. Yeah, and if you want to extend this, although the constraint if it's only 26 letters, you can extend this to all the letters Unicode. And to do that, is basically here, instead of an int of 26, you create a hash map, and then you could have a variable number of letters, right? And that's how you do for that. But I think this question, if you change and do it that way, it works as well. But it doesn't allow you to add a test case for any character that's not A through Z lowercase. I tried. But anyway, that's it for that one. Hey, thank you for watching. If you like this content, please consider making a donation so I can keep doing this for you. I'd really appreciate that if you could donate. All right. Thank you so much, and I'll see you in the next one.